November 17th, 1943. Camp Holabird, Maryland. 29 degrees Fahrenheit, the kind of morning that made metal feel like ice and the air sting in a man's lungs. Across a wide expanse of frozen mud and tire tracks, a flatbed transport truck idled in the pale gray light, its exhaust drifting like smoke from a dying fire. On its trailer sat a strange machine, low, boxy, painted in weathered desert tan, with black crosses still visible beneath a hurried coat of American olive drab. The captured vehicle had arrived from the docks at Baltimore 2 nights earlier under heavy guard, marked only as enemy vehicle, German origin. Now, for the first time on American soil, it was about to be tested. The brass called it Hitler's field car. The men in charge of today's evaluation preferred a simpler term, a problem to be solved. American intelligence wanted to know why German troops could move faster through Europe despite engines with barely half the power of U.S. machines. Some believed the Germans had discovered a secret of efficiency. Others suspected propaganda. Either way, the order was clear: take it apart, measure everything, and find out what made it tick. The camp's motor pool looked more like a graveyard than a laboratory. Rows of tanks with bullet-pocked armor and burned-out half-tracks lined the perimeters, silent witnesses to engineering failure. Inside one of the hangars, a group of mechanics waited for the day's first challenge to arrive. Among them stood Staff Sergeant Jack Rourke, a 38-year-old mechanic from Detroit, his face weathered by factory heat and battlefield wind. 14 years on the Dodge assembly line had given him hands that could read engines like Braille. He knew the language of pistons, torque, and grease-stained patience better than most officers understood their manuals. Before we go any further, take a second to help keep stories like this alive. Tap subscribe and become part of our growing history community. People who still believe the past has lessons worth hearing. And drop a comment telling us where you're watching from. We love seeing how far these stories travel, from small towns to big cities all over the world. When the flatbed came to a halt, the driver killed the engine, and silence returned except for the metallic click of cooling steel. A few enlisted men climbed onto the trailer, unfastening straps and pulling back the canvas cover. The machine revealed beneath looked almost civilian: rounded corners, narrow tires, a simplicity that defied its reputation. The brass said it was German engineering perfection. To Rourke's eyes, it looked like a toy car left out in the cold. The order was given, and the captured vehicle was rolled down the ramp onto the frozen ground. Its tires squealed faintly against the metal surface before touching earth with a crunch of frost. Every eye in the yard followed it. The U.S. Army had captured dozens of German trucks and guns, but this one had drawn special attention from Washington. The War Department wanted answers. Could something this small, this underpowered, really carry German officers across battlefields where American jeeps struggled? Rourke circled the vehicle, his breath forming clouds in the air. The emblem on the steering wheel had been pried off, leaving only a circular scar. The paint smelled faintly of seawater and oil. The body weighed less than he expected. Thin panels of stamped steel welded to a simple frame. Lightweight, yes, but could it survive the mud and snow of Europe's front lines? The test team gathered near the hangar door as the sunlight brightened. Major Leland Foster arrived from headquarters, clipboard under his arm, eyes sharp and unreadable. Behind him came Corporal Ed Ramirez, a quiet 26-year-old engineer from Los Angeles who had once designed delivery trucks before being drafted. Their job was to measure, record, and compare. But for Rourke, the job was simpler. Find out if the myth of German superiority held any truth. Inside the testing bay, electric lights flickered to life, revealing rows of instruments, pressure gauges, torque meters, cables, and the massive dynamometer used for performance tests. The floor was a patchwork of oil stains and frozen footprints. The German car was pushed into position on the rollers. Frost melted off its tires in thin rivulets as the heat from the lamps spread. The hood was unlatched with a metallic snap. Rourke lifted it slowly, expecting to see the intricate complexity that German machines were famous for. Instead, he froze. Beneath the panel sat a tiny engine, air-cooled, horizontally opposed cylinders, barely larger than what might power a motorcycle. No radiator, no heavy iron block, no excess at all. He leaned closer. The metal looked thin, the carburetor simple. It seemed impossible that this delicate machine could have hauled soldiers and supplies through war. A tag stamped on the engine housing read Volkswagenwerk. The specifications printed on the War Department sheet matched what he was seeing: 985 cubic centimeters. 25 horsepower at 3,300 revolutions per minute. Rourke blinked. The numbers didn't lie, but they made no sense. The American Jeep produced 60 horsepower from nearly twice the displacement. Even his father's old Ford from the 1920s had outperformed this. He closed the hood gently and stepped back. The others stared at him, waiting for his verdict. He said nothing, only reached for his clipboard and began writing. By mid-morning, the temperature had risen barely above freezing. Inside the test shed, the air hummed with anticipation as the dynamometer cables were attached to the German car's rear wheels. Major Foster reviewed the checklist while Ramirez calibrated the instruments. The first test would be a baseline measurement: power, torque, and fuel efficiency. Simple numbers that could cut through rumor. The engine coughed to life with a thin, high-pitched buzz. No deep rumble, no growl of mechanical confidence, just the polite whir of an efficient machine doing its best. The exhaust puffed faint white smoke that smelled faintly sweet, like burnt sugar. The sound was almost apologetic, like a typewriter in a room full of type bars. The dynamometer's rollers began to spin. At idle, the engine seemed smooth enough. But as the load increased, the sound changed, a desperate flutter rather than a confident roar. The gauges told the story more clearly than ears could. Peak torque arrived early and weak, tapering off just when power was most needed. The final measurement confirmed it: 25.3 horsepower, exactly as advertised. Nothing more. Rourke jotted down the data. He could already feel the story forming. German engineering wasn't magical. It was practical, limited, even fragile. But that raised another question. If the machines were weaker, how were German armies moving faster, fighting harder, lasting longer? The answer, he suspected, wasn't under the hood. After lunch, the tests continued. Acceleration runs on the test strip showed more disappointment. The little car took nearly half a minute to reach 30 miles per hour. A Jeep could do it in 11. The observers whispered among themselves, half amused, half puzzled. The myth of German automotive dominance was beginning to crack, but no one dared say it aloud yet. Still, there was something elegant about the simplicity of the design. The air-cooled engine needed no radiator, which meant fewer leaks, fewer parts to fail in freezing weather. The suspension, made of simple torsion bars, could flex and twist over uneven ground without breaking. There was genius in its minimalism, just not the kind of genius the Americans had expected. As dusk fell, Frost returned to the test yard. The day's work ended with a thick stack of notes and a growing sense of confusion. The numbers said one thing, the war report said another. Somewhere between mathematics and mud, the truth was hiding. That night, the captured car sat alone in the hangar, its metal shell faintly ticking as it cooled. Outside, the camp lights flickered under the wind, and a guard on night duty paused to look inside the window. The German vehicle seemed harmless, even innocent, a ghost of an enemy that had once believed itself invincible. But the real story of that day wasn't about horsepower. It was about perception. For months, the Allies had been told that German machinery was unmatched, that their engineers possessed secrets unknown to Detroit or Dearborn. The tests at Camp Holabird were beginning to show otherwise. The truth was more complex, buried beneath efficiency, philosophy, and priorities born of scarcity. Tomorrow, the team would test what mattered most: traction, climbing, and endurance. Numbers on paper were one thing. Performance under pressure was another. And in that frozen Maryland dawn that awaited them, a myth was about to be dismantled bolt by bolt. The following morning arrived brittle and gray. Ice had formed overnight on every exposed surface, giving the proving ground an eerie shimmer under the rising sun. From the far end of the yard came the mechanical clatter of engines warming up for the day's testing. Inside the hangar, the German car waited beside an American Jeep that looked larger, heavier, and infinitely more confident. The contrast between the two machines told its own story: muscle and restraint, power and precision, America and Germany, side by side on a patch of frozen American earth. At exactly 0700 hours, the order came down from headquarters: begin comparative field trials. The brass wanted numbers, but what they really wanted was reassurance, proof that America's machines could match or exceed the engineering of an enemy that had conquered half of Europe. Rourke and his team rolled the German car into position for the first test. The incline climb on the east side of Camp Holabird, a half-mile slope of packed dirt and sand that simulated the kind of terrain American troops were facing in Italy. The air smelled of diesel and frost. Rourke climbed into the driver's seat of the captured vehicle, the steering wheel cold and thin under his gloves. The engine started reluctantly, coughing before settling into its familiar high-pitched whine. Across the field, a small crowd of mechanics, engineers, and officers gathered behind a rope barrier, their breaths hanging in the air like smoke. A few laughed quietly, betting cigarettes on whether the little car would make it halfway up the hill. He eased it into first gear and began the climb. The initial movement was smooth, the light frame responding eagerly to the throttle. But as the slope increased, the illusion of strength began to crumble. The engine note shifted from confident hum to strained wail. The tires spun, flinging mud that froze before hitting the ground. The car slowed, fighting gravity, and then, halfway up, stopped altogether. Steam rose from the rear engine compartment, thin at first, then thicker. Patterson, standing near the instruments, read the gauges aloud for the record. Engine temperature spiking, torque falling, horsepower collapsing under load. The German machine had reached its limit. When Rourke tried to restart the climb, the vehicle shuddered, stalled, and rolled back several feet before he hit the brakes. The test was over. Next came the Jeep. The American vehicle started with a deep, reassuring growl that echoed across the field. It climbed the same slope without hesitation, its heavier frame gripping the dirt as if born for it. When it reached the top, the men watching broke into quiet applause, not from arrogance but from relief. For months, they'd been told German engineering was unmatched. Now they had proof that wasn't true. As the vehicles cooled, the data team began compiling results. The German car's maximum sustainable incline, 8 degrees. The Jeep's, 27. The numbers were impossible to argue with. German efficiency had been outperformed by American durability. Yet, Rourke couldn't help but feel uneasy. If their vehicles were better, why were their soldiers still struggling overseas? The question followed him back into the hangar, settling in his mind like a stubborn bolt that refused to turn. The next phase of testing focused on maintenance and serviceability, the kind of tasks that determined whether a vehicle survived weeks in combat or died after a single breakdown. The mechanics set up 2 workstations side by side. On one table, the American Jeep, on the other, the captured German car. Each would undergo the same basic service: oil change, spark plug replacement, and air filter inspection. Stopwatch timers were synchronized. At first, everything looked straightforward. But the German design revealed its true nature in small, maddening ways. The oil drain plug was hidden behind a thick protective plate secured by 8 bolts at awkward angles. Removing it required special wrenches, extensions, and more patience than most soldiers would have in the field. 15 minutes passed before the first drop of oil hit the drain pan. On the Jeep side, the job was already finished. 12 minutes total, drain, replace, refill done. The difference wasn't subtle. It was systemic. By the time Rourke moved on to the spark plugs, frustration had turned to disbelief. The horizontally opposed engine buried its plugs beneath metal shrouds and cooling fins. Accessing them meant dismantling half the top assembly, disconnecting wires, and removing components that had no reason to be in the way. Each plug took nearly 9 minutes to reach. On the Jeep, all 4 could be changed in under 10. He paused halfway through the job, leaning on the fender, his breath visible in the cold. The realization hit him. German engineering wasn't bad, it was overthought. Every part was designed with care, but without considering the hands that would repair it under fire, in mud, or in freezing rain. It was elegance without empathy. Across the hangar, Corporal Ramirez scribbled down maintenance times on his clipboard. His calculations revealed something no one had fully considered. Time lost to complexity was a weapon in itself. A machine that took 3 times longer to repair was a machine that spent 3 times longer off the battlefield. Major Foster entered midway through the testing, his uniform immaculate despite the grease-streaked chaos around him. He watched in silence as the men worked, his expression slowly tightening as he saw the difference in effort between the 2 vehicles. The German car was a masterpiece of design, but it was also a trap, perfect for the engineer's desk, impossible for the field mechanic's hands. The air filter test drove the point home. On the Jeep, it took 3 minutes to open, clean, and reseal. On the German car, it required partial disassembly of the cooling system, 27 minutes in total, not counting the reassembly. Every step added time, tools, and frustration. Every extra minute could mean death in combat. By late afternoon, the results were irrefutable. The German machine was fragile, slow to maintain, and prone to overheating under sustained stress. The Jeep was rougher, heavier, but unstoppable. The myth of German mechanical invincibility was falling apart before their eyes. The team prepared one final demonstration, cold weather starting. The vehicles were left outside overnight as the temperature dropped below 15 degrees. In the morning, with frost clinging to the windows and oil thick as syrup, the engines would face a test that simulated conditions on the Eastern Front. At dawn, the mechanics gathered again. Rourke climbed into the German car, pulled the choke, and turned the key. The starter whined. Once, twice, 6 times. Nothing. The air-cooled engine refused to catch. Vapor curled from the exhaust pipe like a dying breath. On the 7th attempt, it sputtered weakly, then fell silent for good. The Jeep beside it started on the first try, its liquid-cooled engine roaring to life as if mocking its rival. The difference was absolute. Rourke sat for a moment in the German car, listening to the silence. Around him, frost crackled on the windshield, and the faint hiss of the Jeep's exhaust filled the air. For all the talk of superiority, the truth was right there in front of him. One machine was built to survive the lab, the other the battlefield. Inside the hangar, the officers gathered around the data tables. The numbers from 2 weeks of testing painted a clear picture. Less power, slower acceleration, limited climbing ability, poor thermal management, and maintenance times that crippled operational readiness. On paper, the German car was a marvel of efficiency. In practice, it was a liability. But something about the conclusion felt incomplete. Rourke looked over the data one last time, his eyes tracing the columns of measurements, the endless comparisons, the charts of torque and temperature. The truth seemed obvious, yet one question remained unanswered. If their engineering was inferior, how had they come so far? That question would haunt them into the night. For now, though, the tests were done. The captured vehicle sat cooling in the cold air, a defeated symbol of misunderstood perfection. The Americans had come looking for proof of German superiority and found something far more interesting instead. A different kind of intelligence, one that built within limits, not beyond them. Rourke switched off the lights in the hangar and walked toward the barracks, the frost crunching under his boots. Behind him, the little car stood alone under the dim glow of a single bulb. It had failed every test, yet it had carried armies across continents. There was a mystery there, buried somewhere between engineering and doctrine, between theory and the will of men. Tomorrow, he would search for that answer. Night had fallen over Camp Holabird, and the testing ground lay silent except for the wind scraping across the frozen tarmac. Inside the hangar, a single light burned above the workbench where the day's data sheets were stacked in perfect order. The smell of oil and cold metal filled the air. Sergeant Rourke sat alone, his grease-stained hands resting on the edge of the table, eyes fixed on the German vehicle that had defied expectations in all the wrong ways. It looked small now, almost fragile, a machine built for a different kind of war. Every test, every number, every measurement told the same story: underpowered, prone to overheating, complicated to maintain. Yet that same vehicle had carried soldiers across half of Europe. The contradiction gnawed at him. American engineering had crushed it in every measurable way, but on the battlefield, the Germans had been winning. Something didn't add up. Footsteps echoed in the cold corridor. Corporal Ramirez entered, carrying a pot of coffee and a handful of new temperature readings from the earlier trials. He placed them beside Rourke without a word. A few minutes later, Major Foster followed, his heavy coat buttoned to the neck. He had read the day's reports, and like everyone else, he couldn't make sense of the results. The numbers were clear. The conclusions were not. Hours passed in quiet thought, the 3 men studying the data under the flickering light. Torque curves, temperature spikes, maintenance times, all perfectly logged, all damning in their simplicity. It was hard evidence that German engineering was not the unstoppable force the world believed. But numbers alone didn't win wars. Somewhere behind the math lay the reason those vehicles, those armies, still fought with such devastating precision. By midnight, coffee had gone cold, and the frost had crept along the windowsills. It was Ramirez who finally broke the silence. They'd been asking the wrong question, he said. The issue wasn't whether German machines were superior. It was how they were being used. The Kübelwagen wasn't a marvel of power. It was a tool, part of a system that valued coordination over raw performance. Its strength wasn't in horsepower. It was in how it fit into the machine of the German army itself. The realization spread slowly, like warmth from a small fire. Rourke saw it now, The Germans didn't build for excess. They built for purpose. Lightweight so it could be towed, simple so it could be mass-produced, efficient so it could run on less fuel when resources were scarce. Every limitation was a design choice, a reflection of a country fighting on too many fronts with too few materials. They weren't building perfection. They were building survival. For the first time, the data made sense. The Kübelwagen's weaknesses weren't flaws. They were adaptations. It wasn't meant to outmuscle the Jeep. It was meant to move men and supplies farther on less fuel, to operate without radiators that froze, to be built quickly in factories bombed night after night. German engineering wasn't superior. It was strategic, and that, perhaps, was its most dangerous quality. Foster leaned back in his chair, the leather creaking softly. The War Department would receive the numbers, but not this realization. Statistics couldn't measure doctrine or discipline. On the battlefield, training, coordination, and tactics turned mediocrity into advantage. The Germans fought like engineers. They compensated for what they lacked through precision and control. America, by contrast, had the power but was still learning how to wield it. Outside, the wind howled across the proving ground. The hangar's walls trembled faintly. Rourke looked at the German car one last time. It sat there in silence, stripped of its myth but not its meaning. It was no longer a symbol of enemy superiority. It was a mirror reflecting what American industry could learn about efficiency, focus, and purpose. By morning, the report was finished. Technical Manual TME 9-83B, Comparative Analysis of German Light Vehicles. A dry title for what had become a revelation. The document outlined every flaw: 25 horsepower versus 60, a hill climb limit of 8 degrees compared to 27, oil changes 4 times longer, starting failures below 15 degrees Fahrenheit. It left no doubt, America's vehicles were superior by every measurable standard. Yet the final page carried a quiet warning. Equipment alone does not determine victory. Doctrine, discipline, and adaptability matter as much as steel and horsepower. It was an unspoken admission that even perfect machines could lose wars if not used correctly. When the War Department reviewed the findings weeks later, they focused on the numbers. The brass congratulated the Aberdeen and Holabird teams for proving American supremacy in engineering. But buried in the appendix was a single paragraph that captured what Rourke and his team had truly discovered. The enemy's strength lies not in his machines, but in his mastery of using them. By spring of 1944, those lessons began shaping new doctrines. Maintenance crews were retrained to service Jeeps faster in the field. Drivers learned to adapt their tactics, conserve fuel, and coordinate movement with greater precision. The Army had finally started to treat logistics as a weapon. Then came June 6, 1944. Normandy. 16,000 American Jeeps rolled ashore in one of the largest invasions in history. On those beaches, the theories born in that frozen Maryland hangar became reality. Machines that had been tested, refined, and understood performed as designed: rugged, reliable, relentless. Each one a product of lessons learned from studying the enemy's supposed masterpiece. The little German car never ran again. It was stripped for display, its engine removed and stored in a crate marked captured equipment. For years it sat forgotten in a warehouse, a relic of misplaced faith in technological superiority. But for those who had been there that winter, it remained a symbol of something far greater, a reminder that strength isn't found in elegance, but in endurance. The war would go on for 2 more years, and America's factories would outproduce every Axis power combined. The myth of German mechanical perfection would fade, replaced by a new understanding. That real power comes not from design alone, but from how a nation applies it. As victory drew near, men like Rourke and Ramirez would return home to Detroit and Los Angeles, back to factories that had turned civilian industry into the arsenal of democracy. They would carry with them the lessons of that winter: the value of simplicity, the cost of over-engineering, the importance of building for the man in the mud, not the engineer in the office. Years later, when peace returned and the world began rebuilding, Rourke would see the descendants of that captured vehicle on American roads, small, efficient, reliable cars that owed as much to necessity as to innovation. He would think of that frozen hangar, of the nights spent staring at data and realizing that superiority is never absolute. It's earned, refined, and proven where it matters most. The story of the Kübelwagen wasn't just a technical report. It was a moment of understanding, of humility in the face of war, of learning that even an enemy's weaknesses could teach valuable lessons. In that sense, the little car had done its duty twice, once for Germany and once for the men who studied it. The wind swept across Camp Holabird one last time before dawn. The lights in the hangar flickered out, and the silence returned. Only the faint echo of machinery and the steady ticking of a cooling engine remained, fading into the cold Maryland morning. And somewhere in that silence, history shifted ever so slightly, from myth to truth, from admiration to mastery. The War of Machines had revealed a deeper truth about the men who built them and the world they fought to shape. If you've stayed with this story till now, take a moment to keep it alive. Share it with someone who loves history. Give this video a like if these forgotten moments of ingenuity and discovery speak to you. Leave a comment and tell us where you're watching from. We read every one of them. And most importantly, subscribe to the channel. Join thousands who believe that every story, no matter how small, deserves to be remembered. Because in the end, history isn't just about machines or battles. It's about the people who dared to look deeper. Subscribe now, share this story, and help keep these lessons from the past alive for generations to come.